And welcome back once again. Hopefully you've enjoyed doing the lab from the previous module on subqueries, and you're now absolutely comfortable using those. And we're ready now to move on to module 7. We're making riotous progress through this course. What we're going to look at in this module, up till now we've talked a lot about different ways of querying tables and getting back row sets. And it should have become pretty obvious by now that an important part of Transact SQL is working with these sets of data, working with tabular kind of constructs. So what we're going to look at in this module is one or two of the options that we have for generating tables of results that you can then work with in your Transact SQL code over and above just referencing tables directly. So I'm going to talk you through some of the different options that we have for that. Here's what we're going to look at in the module. So we'll start off with views, which is a fairly straightforward part of building databases. And then we'll talk a little bit about some other options like temporary tables and table variables. We'll get into table valued functions, which you have seen before. We talked a little bit about table valued functions when we talked about the apply operator in the previous module. We'll talk about something called derived tables, which you'll find familiar from the work we did on subqueries. And then we'll talk about common table expressions. So there's lots of ways to kind of do the same sort of thing, and it can be a little confusing to kind of understand which one is which, and we'll hopefully make that clear as we go through. So, Jeff, we're gonna talk a little bit about querying views, and I guess the first thing is to talk about what a view is. So how do you think of a view as opposed to, say, a table?
I think it's quite well named in that it's a view of the data. So we're actually looking through this view into the underlying tables. So it's a way of presenting the data that's in our tables. We might want, let's say we have a join. We're spending a lot of time constantly joining the two tables together and selecting from them. What we could do is create a view which actually defines that join syntax within it, and then we can just select from the view as if it were a table. But we're actually viewing through the view into the underlying data in the table. The data's still in the table. It's just a presentation, if you like, of that data.
Right, and that's an important point. Views are they're effectively named queries, as it says on the slide. What we've done is taken the query that we've written, which might be a really complex query that references multiple tables or uses various different constructs within it, and what we've done is we've encapsulated that in a view, and that creates a layer of abstraction over the underlying tables, which can be used to simplify, provide a simpler interface, if you like, for developers to use to query those tables, and also to give you an additional security layer. We can start adding security at the view layer, and then we don't have to worry about people accessing the tables directly underneath.
So you give someone rights to the view without giving them rights
to the table.
So they only see it the way you intend it to be shown.
Exactly. So it's a pretty useful tools. On the slide, you can see the syntax for creating a view. I keep emphasizing this course is really about Transact SQL. It's not about implementing databases. There are other courses you can go on to learn more about that. But we do need to kind of show you just the basics of how you would create a view. So we've got the create view statement. We give it a name, and then it's defined as a select statement, effectively. It's a bunch of SQL that we're encapsulating in that view. And I can then query that view just like I'm querying a table, just as Jeff said. So I can then use a select statement and query from it. And you can see in the example on the slide, we're just selecting some columns from it. From the point of view of writing the Transact SQL, it's unclear as to whether that's a table or not. I happen to have used a naming convention where I've prefixed it with a V, so I know that it's a view. But if I hadn't done that, you wouldn't be able to tell if that was a table or a view. It's pretty much.
So could you even join it to another table?
Yes.
Treat it as if it were a table.
Yeah, so you could create a complex query that includes a view joined to tables and all that kind of thing. You treat it just like a table. There are one or two slight considerations with views when it comes to inserting and updating data, which we don't necessarily need to go into in huge detail in this course. I guess the only thing you probably need to be aware of is if you are updating or inserting data through a view, you can only affect one of the underlying tables that view is based on. And that's one of the restrictions around using views. But other than that, they're pretty much exactly the same as tables. So let's have a look at using views. So I'm in Transact, I'm in SQL Server Management Studio. I've got some Transact SQL code here. And you can see I've got a create view statement where I'm creating a view called vCustomer Address in the Sales LT schema. and it simply selects from the customers table joined to the customer address table, which is where we store all of our address information. And I've got a couple of bits of query in there. It's not a particularly complex query. It has a join where I'm joining the address table. But I want to encapsulate that and make it simpler for people to use that. So if I go ahead and run that piece of code, what that's done is created this object in the database called vCustomerAddress. And because I'm using SQL Server Management Studio, I can actually look in the views folder rather than the tables folder, and I can see that that has been created there. So it is an object that's persisted in the database itself. And now as a developer, I can use Transact SQL to go ahead and reference that view. So I just simply query it just like it's a table, and sure enough, it returns the data that I need, the customer ID and the city that that customer is living in. And similarly, I can treat it, as we said, just like a table. So I can join it, I can treat it the same way I would do with any other table, join it to other tables and all that kind of thing. There's no real special consideration just because it's a view. So in this case, I'm joining it to the sales order header, and I'm getting the customer address information and the order information. And if I go ahead and run that, you can see that I'm getting back the revenue broken down by state and province and then by city. So I'm encapsulating some of the complexity in a view and then building a more complex query on top of the view, just as if it were a table.
And then could you even create a view of that new definition that you've now got?
Yeah.
Because if I do that a lot, I can reduce the code again.
Absolutely, yeah. I can create a view that references a view, so I could take that as far as I really need to go, and create a layer of abstraction over the underlying tables that just makes it easier for either reporting applications to use or for applications that developers are building to interact with the database to use. So moving on from views then, temporary tables is something that we might want to talk about. Views are persisted in the database, whereas temporary tables, as their name suggests, are temporary. So here's a little example. You'll notice that a temporary table is always, its name is always prefixed with the hash symbol, or the pound symbol as we call it in the UK. So of course it's hashtag temp products in the modern parlance. But yeah, it's a table called temp products. It's a temporary table. That's why I have the hash marks in front of it. Other than that, it's created pretty much like any other table. We create the column names and we specify the data types and all that type of thing. I guess one thing that we need to be aware of that, temporary tables, they aren't actually created in the database that you're working in. They're created in a separate temporary workspace database that in SQL Server is called TempDB. And in that database, they're maintained by the system. So they're there until they're no longer required, and then they're automatically deleted and that space is reclaimed. But they do take up resources in the TempDB database. So there is a consideration there. You can also create, the ones we've got here are scoped to the current user's session. So with that single hash mark in front of it, it means that in this session the user can work with that table, and at the end of the session the table gets deleted, it gets torn away. And I guess the final point to make is, as it says in the slide, if you want to make a temporary table that spans multiple sessions, that's a global temporary table, then you prefix it with 2 hash.
And then you could pass values between sessions.
Yes. Yeah. It begins to get pretty complex that way, and to be honest, if you've got a database application that relies heavily on temporary tables, it's probably an indication that the design of the application isn't that great, because they do tend to use resources, spinning them up and then tearing them down, and in the meantime taking up space in the TempDB. So that being said, an alternative approach, it might be to use table variables, which in some ways are very similar to temporary tables. And they were really introduced largely because temporary tables can cause recompilations of queries. We're getting perhaps into the nitty-gritty of how the internals work here a bit much, but if I've got Transact SQL procedures that are querying temporary tables, because those temporary tables are being dropped and recreated, that compiled query that's used to query it will get recompiled the next time, and you end up with an awful lot of recompilations of queries that use up system resources. Variables are a way of getting around that. So we've got a variable here in this example. It's prefixed, instead of with the hash symbol, it's prefixed with the @ symbol. That's how we know it's a variable. We declare the variable, of type table. And of course, we can have variables of lots of different types. You have variables of string or integer or whatever. Table is just another data type as far as variables are concerned. And then from then on, we effectively define it the same way we would define a table with columns and data types. And you can then treat it just like a table. You can select star from your @ symbol var product in this case. So they are similar to temporary tables. They're scoped to the batch, not to the session. And we'll talk in one of the later modules when we get into talking about programming with Transact SQL. We'll get a bit more specific about what these things mean. But for the time being, what we're saying is that if you create a temporary table, you can then continue using that until you disconnect that session because it's scoped to the session. If you create a variable, it stays in scope until you finish running the current set of execution, the current set of Transact SQL commands that you've got in scope. So if you have a go command in there in your client tool, that will end that batch and start a new batch. If you just select some code and run it like we've been doing in the demos, that's a batch. And once we finish that batch, the variable goes out of scope, so I couldn't then reference it again. It's only available while we're in that batch. And the other final thing to say is, generally the recommendation is to use these things on relatively small data sets. Don't take your entire product catalog and stick it in a variable thinking that will improve performance, because it won't. If you want to improve performance by having data in memory, there are much more sophisticated and clever ways to do it than by just shoving it into a variable. They're great for something where you just need a little tabular store of data for a temporary operation as a kind of holding space. They're not really designed to take large volumes of data. You can do, but you'll find that the code runs pretty slowly. Anything to add about variables or?
Well, only that we'll talk about variables more later in the course, that we haven't really introduced the concept of a variable, but we will go in depth about the different types of variables and what they're for and passing values to them.
Okay, so in the slides we talked about temporary tables and variables. I just want to kind of show you those in this demo to try and clarify the use of them. So we'll start off with a temporary table, and you can see I'm going to create one called colors here. I want to just temporarily store all the colors that we have. So it's only got one column in this case. It's a varchar column of 15 characters, and I'll just go ahead and run that code. And that creates this temporary table. Now, it's not going to be listed in my list of tables. I could refresh that and it still wouldn't be there. It's actually created as a temporary object in the TempDB system database. But I can treat it just like a table, so I can insert some data into there. And off I've gone and inserted some rows into there. And then I can start selecting from it just like any other table. So I'm getting my list of colors back from that temporary table. So that's fairly straightforward then. It's pretty much working with a table. A table variable is pretty similar. I declare it as a variable of type table, and I specify the column. So again, we're creating one column in this particular variable called color. And if I just select that and then try to insert into it, I get an error that says the variable isn't declared, and that's because it's scoped to the batch of commands. So it doesn't hang around.
That worked, didn't it, when you did the temporary table?
Yes, it worked with the temporary table because it's scoped to the session, and it would continue to work. I could still work with my temporary table now until I actually disconnect this session, and then that temporary table will disappear. But if I'm going to work with a variable, I have to do everything in the one batch of commands. So I'm going to declare the variable, insert the data into it, and then select from it, all in the one batch of statements. So if I go ahead and run that, then it works, and I get my data coming back. But if, of course, I then start a new batch, well, I can still get to my temporary table, as we saw, but my variable is now out of scope, so it's gone. So it's more temporary than a temporary table, if you see what I mean.
And can we, like views, could we treat these things as tables? We can maybe do a join to something else?
Yes, once they're declared, as long as they're in scope, they behave just like tables. I can select from them, I can join them, I can do all that type of thing. Table-valued functions is the next thing that we're going to talk about. And we saw functions previously. We saw functions when we looked at the apply operator in the previous module on subqueries and apply.
We did the SP help text.
And we used SP help text to actually see the definition, yeah. So you should be familiar with functions, at least in a passing way. You've seen them in the previous module. A table valued function, as its name implies, is a specific type of function that returns a table. So it's an object, again, a bit like a view. It's stored in the database. It's a permanently defined object that lives in the database. And it returns a virtual table to a query that calls it. So in some ways, it's kind of like a view in the way that it's persisted. The major difference is that we can parameterize these things. So we saw variables just a short while ago, and we saw table variables. Variables could be lots of different data types. So I could have a variable that is an integer or a string or whatever it might be, or varchar, I guess we should call it. And those variables, if I use those variables as being parameters, I can pass values into a function. It will then use those parameters within the function and return a table based on that. So in the example that we've got here, it's a function that takes a parameter called order ID, which is an integer. It returns a table, and the table it returns is defined by that select statement. And what it's returning is the details of the order that has that order ID that we've passed in. So it's a little more flexible than a view. I don't have to have a where clause when I query it. Instead, I pass in a parameter.
And does this thing carry on existing, or does it vanish when we've finished our statement? Or
no, just like a view, it's an object that's defined, it's stored in the database, and I can actually see it in my database and come back to it again and again and again, and reuse it with different parameter values every time if I want to. So in this demo, we're going to look at a table-valued function. And a table-valued function is a function that's created, that defines a query, that may accept parameters and returns a tabular set of data. So I'm creating a table-valued function in the sales LT schema called UDF customers by city. And the UDF, user-defined function, is just a naming convention to help me realize that this is a function. I'm passing in a parameter, or at least I'm going to define a parameter called city, which is a varchar 20-character string that we're going to pass to that, and it returns a table based on this select statement, which is a select statement that has a join, and again is based on passing in the city. So it's going to return all of the customers that live in a specific city. So if I go ahead and create that function by running that code, command completed successfully. And it doesn't show up in my tables, it doesn't show up in my views. If you really want to see this thing in SQL Server Management Studio, you have to go exploring in the programmability folder, and then in functions, table valued functions, and we should find that I have my UDF customers by city function in there. So now that I've got that function, I can use it, and I use it by a bit like a table, select from it, so I can select individual columns, or I could select all of the rows or whatever. Select star from this function, and I pass in a parameter in parentheses. So I pass in the city of Bellevue, because that's the one I want to see my customers for. And what I get back is the customers who are based in that city. Now, derived tables, we saw in a previous module subqueries. And you can think of derived tables as being subqueries that return an entire table that might have multiple columns. So some of the subqueries we saw previously, there were scalar subqueries that returned a single value, and there were multi-value subqueries that returned effectively a table with one column, an array in programming terms. These derived tables are subqueries that return a multi-column table. So we're returning a table that has multiple columns. And there are a couple of rules around the way that we use these things. So the first thing is that they're named query expressions. They're created within a select statement. So they aren't permanent objects. They're not stored in the database or anything like that. They are a virtual table for the purposes of simplifying a query effectively. The scope of the derived table, unlike a temporary table or even a variable, they're not even scoped to the batch, they're scoped to within that statement, within the select statement in which they're defined. As soon as that select statement finishes, the derived table no longer exists. So it's purely a programming construct within a select statement.
So if we had the same piece of code within a select statement that we repeated, you could use it for that. You could essentially name it, if you like, and then refer to it in that way.
Yeah, exactly. So some guidelines for using these things. They must have an alias. And in the example we saw previously, we had the entire subquery encapsulated in parentheses, and then at the end of it was as, and we gave it a name. So just in the same way that you apply aliases to tables in a select statement, if you're going to join them quite often, you have to apply an alias if it's a derived table. It has to have a unique name for all of the columns that it returns. So if the derived query itself references multiple tables and those tables have the same column name, like a product has a name column and product category also has a name column, you have to assign aliases to those columns to make sure they're unique. You can't use an order by clause in the query. You can use an order by if you have a top or offset fetch in there, but other than that, you can't just apply an order by to sort the data for, arbitrarily in a derived query.
So if you desperately wanted to, you could do a top 100%.
Yes.
With an order by.
Yeah, performance-wise, probably at that point, I think that's probably not the right way to do it. But yeah, I guess that would be one way around.
But you should be doing the order by in the final part of the select statement.
Exactly.
Anyway.
Remember, your derived tables within a query. So if you want to order the results, order them in the outer query rather than in the inner query. You're not allowed to refer to them multiple times in the same query. So we talked about views being able to use them again and again, and variables being able to again and again. These guys are defined within a query, and you can't use them multiple times in that query. You can only use them the once. There are some additional things you might want to think about, though. They can use internal or external aliases for columns, and we'll talk about the difference between those two on the next slide. And they can refer to parameters and variables. So if you have declared variables, you can use references to those variables within the query. So your derived query could in fact reference a table variable and then query that. And they can be nested within other derived tables. So I could have a query that contains a derived table, that contains a derived table, that contains a derived table. So you are able to kind of reuse them in that sense. You can nest them within one another. So I talked about the two different types of column alias, and I guess the most intuitive way, if you've been working with Transact SQL for a while, you're probably used to defining aliases in line. So when we've got that example here, you can see the derived table is the inner query, if you like. It's in this in parentheses here. Select year, order date, as order year. So I'm creating the definition of the column name as an alias actually in the select statement of the derived query itself. And then I finish the derived query and then give it a name as derived year. So that's a fairly intuitive way to add column aliases. The other way that you can do this is you could actually use them externally to the derived query. So in the query itself, I'm selecting the year of the order date, but I haven't assigned an alias there. What I've done is I've waited until I've completed the definition of the query, given it a name as derived year, and then in parentheses after that, I can declare the names of the columns. So either of these syntaxes is perfectly acceptable. Let's see an example of derived queries. So in this case, I have a table that I want to get some data out of. So I'm getting the category and the number of products within that category. And I'm doing that not from a table, but from a derived query. So I've got an outer select statement that contains an inner select statement, which defines a derived query with the name prodcats. So I'm selecting in the derived table, I'm selecting the product ID, the name as product, so I'm using the inline convention for naming the column names of the derived table, and name as category. From the product table, join to the product category table, and then giving that the name prodcat. And I'm then, once I get the results from the derived table, I'm back to the outer query again, and at that point I'm grouping by the category and I'm ordering by the category. So as we saw when we worked with scalar subqueries, I can go ahead and I can select the entire definition of that subquery just to test that it works. And if I run that, I can see this is what my derived table is going to look like. So that's what I'm selecting from in the outer query. And if I go ahead and run the entire thing, I'm then able to group into the categories and get the count. Now, derived queries are straightforward to use if you're used to using subqueries, but I'm sure you'd agree, Jeff, that the syntax can be a little bit complex. Once you've got queries within queries, it can be quite confusing, yeah?
Yeah, it does seem like there's some of these things we could do in other ways, but we're just adding complexity and to understand the code.
Right, and I think for that reason, a lot of people prefer to use this alternative technique, which is a common table expression. So with a common table expression, in a similar way to using a derived table, you're defining a temporary tabular object that you're going to use within the scope of a query. These things are again named table expressions, so they have a name and they're defined within the scope of a query. But the way that we define them is we have this with clause, so with CTE year, and then I've got my column names. And again, like a derived table, I could do that here after the name, or I could do it in the query itself. I'm creating a thing called CTE year as, and then in parentheses I've got the query that defines that. So I'm doing the inner subquery right up front. It's a bit like when you write a C# program or any other language. Usually it's good practice to declare the variables at the top. So you declare all those variables so you can see the declarations of what you're going to use before you use it, rather than declaring them as you go along. Similar idea here. I'm defining the common table expression at the beginning of the query, and then later on in that query I can reference it and I can use it. So this is really an alternative way of doing what we saw with derived tables. There is a difference. These guys support multiple references, so I could refer to this multiple times. I could query from that common table expression again and again in the same query, which I can't do with a derived query.
But it won't live on like a view?
No. Once the query that contains it ends, then it goes out of scope and it disappears. But while it's in scope, I can hit it multiple times. And the other thing it supports is something called recursion. Now, some of you who are programmers might be familiar with the idea of recursion. In programming terms, it usually refers to a function that calls itself. So the function calls its own function and iteratively works its way through a kind of recursive loop of processing. In this case, we can use a common table expression if we have a table that defines a hierarchy. And again, when we talked earlier on about self-joins in one of the previous modules, we had an example of employees who have managers, and managers are themselves employees. Similar idea, we can use recursive queries in CTEs to deal with that. So here's the kind of example of how we might do that. I've created a common table expression called org report, and it consists of a manager ID column, an employee ID column, an employee name, and the level within the hierarchy that employee lives at, with 0 being the managing director at the top, and then 1 the direct reports to there, 2 the direct reports to those guys, and working your way down through the levels of the company. So the way that we create a common table expression for recursion is slightly different to just a regular common table expression that defines a table of data, because what we actually have to do is use 2 tables. So we start with what we call the anchor query, and effectively what that's doing is getting the top level of the hierarchy. So in the employees example, it's getting the person at the top of the tree, the person who has nobody reporting to them, who is the CEO or the managing director. And that anchor query, in this case, we're selecting the manager ID, the employee name, and we're actually literally giving the value 0 to the level. We're saying this is level 0, this is the top level. From the employee table, where the manager ID is null. So we're getting everybody who doesn't have a manager there at level 0. Then we're back to some familiar syntax. We're using a union all statement. So we're eliminating we're assuming there aren't any duplicates, and if there are, we're going to include them. We're doing a union all. We're getting the manager ID, the employee name, and then we're adding 1 to the level, which was in the anchor query. So we're now up to level 1, and then the next time it would be level 2, and then level 3. And off we go and get the employees and their manager IDs.
But you're actually joining there to org report, which doesn't yet exist, because actually that's itself.
Exactly, yeah. We have an inner join at the end. This is the recursive join. This is joining back again to my common table expression. So I've partially declared the common table expression, and as part of the definition of the common table expression, I'm using the common table expression, which is, again, that classic recursive programming. It's a bit of a head scratcher, but that's how it works. So because I've done that, I can then, once I've declared this, I can then select from it. I've got my anchor query union to my recursive query that goes back through the same CTE again and again. I can select from it, and one of the options I can use, you don't have to, because by default this is going to go through and get every single level of employee that there is. Because recursive queries can be quite an overhead, what I might want to do is say, well, I don't want to go and get the entire organization structure. If it's a small, mom and pop store, as they call it, organization with, maybe up to 20 employees or something and 3 levels of management, then that's fine. If it's a large organization, a multinational that has hundreds of levels and potentially hundreds of thousands of employees, you probably don't want to go all the way through them just to generate your org chart. The query will be... If you
haven't thought about your logic properly, could you end up with an infinite loop, effectively?
Yeah, in theory,
it just carries on forever.
Yeah. So, we go on until the server run out of resources, effectively. So, to avoid that kind of situation, you can specify the max level of recursion you want to get to. How many recursive iterations do I want to allow? And in this case, I'm saying max recursion 3. So I'm getting to that third level and then stopping. So we've got the definition of the anchor or the root level query, and then we use the union all to add a recursive query for all the other levels that loops back upon the same CTE. Okay, let's look at an example of a common table expression. So we've got a query here that has a with clause at the beginning that declares the CTE, and we're given it product ID, product name, and category as the names of the columns that come from there. And within that with statement, here's the query that defines the common table expression. And again, just like a subquery or a derived table, I can run that code and see this is effectively what's going to be returned by my CTE. And then outside of that, I've got a select statement that references the CDE. So products by category is the name of the CTE, and I'm referencing it just as if it were a table here and getting back the count of products by category ID. So if I run all of that as one statement, sure enough it works. So I've broken out, logically in my query, I've broken out the bit that gets the inner query into a separate CTE, and then I'm querying it below. And I think that's in many ways much easier to read and easier to work your way through than using a subquery to create a derived table. Now, that's one use of a CTE, and it's effectively an equivalent of using a derived table with an alternative syntax, I guess. The other real use of a CTE is the recursive idea that we talked about previously. So to explain that, I'm just going to remind you of the employee table that we created earlier. And what we've got in here are all of my employees and the ID of their manager, except for employee number 3, who is the managing director, who doesn't have a manager. So we have a hierarchy of employees. And previously we used a self-join to query this. This time we're going to use a CTE. So I'm just going to get rid of the grid at the bottom there so we can see the whole query. And what I'm doing is defining an anchor query that gets the manager ID, the employee name, and I'm hard coding level 0 because this is the root level. I'm unioning the results of that to the recursive query, which gets the manager ID, the employee name, and whatever level is plus 1 from the employee table joined back to the CTE again. So that recursive join that makes the thing recursive. And I'm then going to select from this CTE with a maximum recursion level of 3. So I only want to go 3 levels deep into the hierarchy. Any further than that, I want to flag an error so that we abandon the query effectively. So let's go ahead and run that query. And sure enough, I get level 0 is my managing director here, who doesn't have a manager. And then level 1 are the kind of supervisory level, if you like. And then level 2 report to level 1, and level 3 report to level 2. So you can see how I can use that. It's in some ways more intuitive than using a self-join, because we're able to actually bring back the levels and define how many levels we want to get out of the query. And
you couldn't do that recursive technique in those other table expressions that we've seen. We couldn't do it in a table function or...
No, only in a common table expression can you use that approach. So if you need to do a recursive query, CT is pretty much the only way to go. So that was our lap around table expressions. As you can see, there's lots of ways to do effectively similar things, to bring back some sort of tabular structure of data that we're then going to treat as if it were a table. So we've seen views, which are effectively queries that we then save with a name, and we can then reference those later on as if they were tables. Temporary tables, which are, as their name suggests, tables that are defined temporarily, and usually they're defined at the scope of the connection or the session, and when the session finishes, the table is automatically deleted. We saw table variables, which are in some ways a more efficient alternative to using temporary tables, but they do have that consideration that they're defined at the scope of the batch. So as soon as the batch of statements goes out of scope, we lose the variable. We saw table-valued functions, where you define a function that could accept a parameter and then returns a table, and then we can query that as if it were a table. We saw derived tables, which are effectively subqueries that are named and return multi-column tables to the outer query. And then we saw an alternative approach to doing similar thing to derived tables called common table expressions, where we separate out the definition of the query that we want to use for the table ahead of actually using it. And it has the added benefit that it also supports recursion, so we could do those recursive queries into common table expressions. So lots for you to explore in the lab. Lots of different types of table expression that you'll be challenged to use when you do the lab for this module. Chance to get hands-on with all of these. And then when you're comfortable with all of those, come back and join us for the next module in this course.